Hello guys, welcome to another question from GATE 2020 and this is question number 52. The question says, the crack growth is being continuously measured in a test specimen subjected to constant amplitude cyclic stress with a mean stress of 0. The crack growth rate is related to the stress intensity range delta K and it is given by dA by dN, which is nothing but the crack growth rate is proportional to delta K cube. So what is this guy? This is nothing but my crack growth rate. Okay. And delta K is nothing but the change in the stress intensity or the range of the stress intensity. So what is this law called as? So if you have something like this, dA by dN is proportional to delta K power some integer m. This is my Paris law. Okay. So the Paris law is actually helping us to understand how the crack growth rate is changing or is dependent with respect to the stress intensity range. What is N here? N is the number of cycles and A is the crack length, obviously. Okay. So here they also gave that when the crack length increases by a factor of 2, the crack growth rate will increase by how much? Okay. So here for that we have to just simplify the delta K. Okay. We know already, right? So KIC is what? Sigma times root pi A. Okay. Or pi AC. Or if I just write KI, I can write this. And what would be delta K? So delta K would be equal to delta sigma root pi A. Okay. That's all. This would be your delta K value. Okay. Now if you carefully see what they are telling, when the crack length increases, that means what is crack length here in the equation? A. So we are trying to relate delta K and A. So delta K is proportional to root A. Okay. So from here I can say, maybe let me just write it a bit. Yeah, delta K is proportional to root A. This is the equation. And now if I just write that what is happening to delta K if A is increasing, I can easily do that, right? So let us take two scenarios, 1 and 2, case 1 and case 2. So in the case 1 it would be delta K1 divided by, in the case 2 it is delta K2. This is equal to root over A1 by A2. Okay, simple. Now also we know that from here we can say that the crack length is increasing by a factor of 2. That means I can write A2 is equal to 2A1. Okay. So if this is the case, what will I get here? Delta K1 by delta K2 would be equal to root over A1 by 2A1. So this gets cancelled and from here I can write delta K2 is equal to root 2 times delta K1. Okay. So if the factor, if the crack length is increasing by a factor of 2, what is happening? The delta K is also increasing by a factor of root 2. Okay. So now if you just see, if you just what they're asking about, they're asking about the crack growth rate. So let me just assume that dA by dN is equal to some x value. Okay. What is it? dA by dN equal to some x. I'm assuming this. So that means x is proportional to delta K whole cube. That is what is given in the question for us, right? So from here I can write again x1 by x2 is equal to delta K1 by delta K2 whole cube. Okay. So again I have the equation here. So what I'll get from here? x1 by x2 is equal to, what is this? Delta K1 divided by root 2 times delta K1 into whole cube. So this is getting cancelled out. So what you are left with is x1, or I can directly write x2 is equal to 2 root 2 times x1. This is what they are asking, right? If the crack length is increased by a factor of 2, by what factor the crack growth rate is increasing? So here you can see, right, crack growth rate, I have assumed it to be x. Okay. So from here I can write 2 root 2 is what? 2 root 2 is approximately 2.8. Okay. 2.8 times x1, right? So the answer would be 2.8. So if the crack length increases by 2 times, the crack growth rate increases by 2.8 times. Okay, so this is how we use different concepts, right from Paris law to the stress intensity factor, and slowly we'll try to interlink different equations and we arrive at what we want. Okay, so that's it for this video. I hope this video is clear. Thank you for watching.